Algebra II, 4.2d, Cramer's rule for two equations. If you haven't seen the previous videos for Chapter 4, you might get confused, especially 4.2a, b, and c. And there's links in this video's description to watch those first. Cramer's rule is named for Gabriel Cramer. He lived from 1704 to 1752. That's kind of young. He was only 48 when he passed away. He was a Swiss mathematician, astronomer, and philosopher, and he earned his PhD when he was only 18 years old. He was a child prodigy. Now, aside from solving systems of equations by graphing, using the substitution or elimination methods, we can use Cramer's rule. Gabriel Cramer developed an algorithm, that's a process or set of rules to be followed to solve large systems of linear equations. And we're going to discuss the general system of two equations. So I hope you have pencil and paper because there's no way you're going to remember all of this. It's going to get kind of crazy, okay? So to use Cramer's rule, we first need to write our two linear equations in this form. And if you notice, this first equation has all these little 1 subscripts, and the second equation has all these little 2 subscripts. Well, that's no different than when we were doing the slope formula with the y2 and y1 and the x2 and the x1. Same thing. It just lets us know which one is which. So by having these little subscripts, we know that this a is coming from the first equation and this a is coming from the second equation. Okay? There's these tiny little numbers. That's what subscripts are. All right? So now we need to assign d to represent the difference of the two products of the coefficients of x and y. And that d is going to be our denominator. We use this formula, a1 times b2 minus b1 times a2. Now, it's extremely important to follow the correct order of subtraction. No different than if you were doing the slope formula. You have to think of it as crossing in a square. That might help you. So if you make a square and you put a1, a2, b1, b2, what we're doing is we're multiplying a1 to b2, see? And then we're subtracting b1 times a2, see? We can find the values of x and y by dividing. X, the formula for x is going to be c1 times b2 minus b1 times c2. And it's going to be over that denominator, whatever it is. So here's that denominator formula down here for the denominator. And then this numerator is just the same thing as this. That's all. All right? To find y, we're going to do a1 times c2 minus c1 times a2. And that's going to be over our denominator. So once we know what the denominator is and we do that formula, it won't look so busy because all of these a's and b's will be gone. Okay? We can also look at the x and y as the little boxes. If you look at x, it's c1 times b2. Well, just put c1, c2, b1, b2, and come down across this way and multiply and subtract these guys multiplied together. See? And for y, you go a1, a2, c1, c2, and we're going to multiply these together and subtract these that are multiplied together. Okay? So here's our system of linear equations. We've got two equations. Here's our first equation, 13x plus 7y equals 25, and our second one is 10x minus 9y equals 13. So the first thing we're going to do is find our denominator d by using that formula. And you can see that a's are all purple, b's are all blue. So we've got a1, which is 13, and we need to multiply it by b2. That's at negative 9. Then we've got b1, which is the 7, and that's going to be multiplied to a2, which is the 10. 13 times negative 9 is negative 117. 7 times 10 is 70. We need to subtract it, and we get negative 187. So now we have our d. And that's going to make this a lot easier on the eyes because now we can just write 187 underneath all of these, okay? Now we need to solve for x, and the formula for that was c1 times b2 minus b1 times c2. Well, c1 is the 25, isn't it? And b2 is this negative 9 here. So we're going to do 25 times negative 9. Then we're going to subtract b1, which is the 7, times c2, which is that 13. So now we've got 25 times a negative 9 minus 7 times 13. That's going to give us a negative 225 minus 91. And when we subtract, that's going to give us a negative 316. These are both negative, so we can turn this into a positive. And that is our value for x. 316 187ths. Whew, that's quite a fraction, isn't it? Now, because 316 187ths is such a difficult fraction to work with, we wouldn't want to solve our system with substitution. That would drive us crazy. So Now we can use the formula for y, and that was a1 times c2 minus c1 times a2, all right? So that means a1 is 13 times 13, okay? We got 13 times 13. Then we got c1 times a2. So now we've got 25 times 10. We need to subtract from that other one. So now we've got 13 times 13 minus 25 times 10. That's going to give us 169 minus 250. That's going to give us a negative 81. And it's still over our denominator. The denominator hasn't changed. And because these are both negative, we get a positive 81 187ths. We could check this by substituting the 316 187ths for x and the 81 187ths for y into both equations, and it'll show us that our solution is correct. That's our ordered pair. Now, if we get a 0 for d, we can't divide by 0. That's undefined, isn't it? So if d ends up becoming a 0, well, then something's wrong. Well, it means that there's either no solution and the lines are parallel, or there's an infinite number of solutions and it's the same line. And Cramer's rule won't work, and we'll have to use either the graphing, substitution, or elimination method to do those, okay? So the Cramer's rule method is a bit more complicated. It takes a lot longer, but it's worth it when the answers are these very big, ridiculous fractions, see? So if we have an ordered pair that's going to come out like this, Cramer's rule can really help us. Now our next video is 4.3. We're going to talk about how to change word problems into a system of equations. I'm going to add this video to the Algebra II playlist so you can use it to catch up on any videos you've missed or review. And there's going to be a link to the Chapter 8 playlist from Algebra I for systems of equations. If you're really lost about systems of equations and you don't remember from last year, you can just click on that. And of course there's going to be links to those previous videos, all right? Okay, this was quite a lot of information. I hope you understood it. It is very long and drawn out, isn't it? But I hope it helps, and I'll see you next video. Bye.